Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is one MCQ and the question in front of you. So I request you please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe we have tried, so let's start. The question is, which of the below mentioned diene has minimum stability? Read carefully, minimum stability. Or you can expect that who is more maximum reactive. Both could be asked in this way. Now, if you look at diene, you need to understand first their stability. So let's go a little bit in order to learn about the stability of diene. So dienes are stable. Why? Because they have a conjugation. Conjugation means you can expect that this double bond comes here, it goes there. So in this way, one side positive, another side negative. By the way, another canonical form also possible. It will come here, it will go there. So this way you can write that positive charge is here, negative charge is here. So what is the overall message? That there is a electron delocalization. So electron delocalization means stabilization. By the way, sometimes you can ask, sir, we heard that compared to a simple alkene, dienes are more reactive because of they are homo energy higher. By the way, I've already discussed a dedicated lecture explaining this thing. So please visit for further learning. I am not talking about chemical reactivity. I am just talking about the stability. And this stability comes from this resonance. So this resonance or delocalization has one consequence. What consequence? Because more the delocalization, more is the stabilization. So here actually the question asked here, who has maximum resonance stability or maximum resonance? If you look at option A and option B, this methyl group is actually far away, so resonance possible. In this case also possible, but you can expect, sir, there is expected to be little amount of steric repulsion between these two hydrogens. I agree with your statement. So these hydrogens and these methyl have a very weak steric repulsion, fine, but that not doesn't that much interfere. Overall the delocalization energy of this double bond is more, so still B is delocalized, stabilized. But if you look at option C versus D, there is a story, because the group is actually tertiary butyl. Student, tertiary butyl is actually a very big group. Why? So 3 hydrogen, so you can consider 3 hydrogen. You can, if you want to know the bulkiness, just look at here. This is a far more bulky, this t-butyl, because of this 3 methyl group. So here this bulky part is there. Now if you look at this option D, what happened? There is a hydrogen, okay fine, and there is a hydrogen. Now who is expected to face little more interaction? So these hydrogen, this methyl group, I mean CH3 there, but still acceptable. That doesn't create any problem that much in this delocalization, and it can undergo one thing further. Even we know that these dienes, I am drawn here the trans version in all cases, they can undergo this CC rotation to prepare this cis-1. Obviously there is some rotational barrier, because in this two canonical form you can see this CC bond C2 C3 have some partial double bond character. Okay, so fine, we got it. So rotation is possible. So if you look at trans is more stable, because in this case this trans, two big groups are far away from each other. Now if you look at option C, this is a story. So if you look at here, this is a trans version. This hydrogen, this hydrogen, this hydrogen, this hydrogen. Student, I suggest you, for this problem please draw by yourself. More you draw, more you remember. Now there is this CH3, this hydrogen, there is a severe repulsion. Even these hydrogen, this CH3, severe repulsion. So this makes the molecule little less stable. Now another option. So if you rotate this CC and make it a cis double bond, so this. Now in this case there is even further steric repulsion. So this is one tertiary butyl and this is another. So from there you can understand one thing, that sir, this steric repulsion is maximum in case of cis, so cis form will not be attained. Now what is the another option possible? So neither cis nor trans, because in cis trans fashion there is a steric effect or repulsion. In cis also steric. So where the molecule will go? Molecule will attain one thing, out of planarity. What do I mean? So you can expect that this molecule, this CC bond rotation will happen, and this one, you may consider this side is in plane and the opposite side will go 90 degrees, such that these interaction means with hydrogen and this tertiary butyl interaction could be minimized. So because of this out of planarity, no resonance between the CC double bonds, two double bonds, there is a no resonance. So that was the main factor for their stability of this diene conjugation. So that is actually lost. By the way, let me draw one thing, student. So there is one double bond, I mean pi bond, there is one pi bond. So they undergo conjugation to produce, this is the pi and this is the pi star. So because of this conjugation, what they do, they prepare this pi and pi star. So overall, another thing they are LUMO conjugate. So this is talking, I am about the conjugation. Because of this higher energy of this pi star, which is acting as a HOMO, highest occupied molecular orbital, they are more reactive for reaction with electrophile. Lower energy of the, sorry, it's not pi star, it's an anti-bonding, you say. This is pi bonding and this is anti-bonding. That's a more accurate because pi star will be above. So they show more reactivity. But this delocalization creates some stabilization for diene, which is obtained by one term called heat of hydrogenation. This is actually a proof whether dienes have really delocalization energy or not. I have already uploaded a dedicated lecture. Please visit for further learning. So from these we understand one thing, that the minimum stability, if I say, this is because of this option, and obviously this is because of steric repulsion, out of planarity arrangement. By the way, if you got this question, how can you get the right answer? Logic is that when you see methyl, you say no sir, not that much less repulsion, fine. So option A and B gone. Minimum stability I am talking, so that should be more repulsion or destabilizing factor. Now when you look at tertiary butyl group, there is a, okay sir, there may be, but in this case these two tertiary butyl groups are far apart each other. So in cis form, okay, there may be a little bit, but from trans form, little bit stable, and there is some repulsion, I agree, which is far less compared to these one I have explained in cis form, trans form, both from associated with very high steric repulsion. So this will attain out of planarity and the conjugation loss. So the reason for that stability is lost. So this has minimum stability. So this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.